Welcome to the lair of the Batty Boffin.
Hi there Batty fans, it's time for a little more Batty Boffin chemistry, and we're talking about the periodic table and particularly about the group 7 elements, the halogens. Here's a quick reminder of where they come on the periodic table. Now, in earlier ones, we've talked about the structure of the electrons and the tendencies as they go down the periodic table and all that kind of stuff. Today we're going to be talking about some of the common reactions with them. The order of reactivity is very important, so if you're not sure about that, go and check out some of the other videos where we talk about fluorine, chlorine, bromine and iodine. It's important that you know which ones are more reactive and which ones are less reactive. Just as a quick reminder, mega reactive, not quite so reactive, and they go down. So reactivity decreases as you go down the group. But if you're not sure about that, check out one of the earlier videos. In this first section here, we're going to talk about a very common displacement reaction. What I've got here is a little test tube filled with an aqueous solution. That just means in water. An aqueous solution of, let's have potassium iodide, I think. So in there, we're going to have potassium iodide, Ki. Okay, it's a bit like sodium chloride, you know, the salt you put in your fish and chips. Instead of sodium, we're having potassium, and instead of chloride, we're having iodide. So instead of sodium chloride, this is potassium iodide. It's another salt. It's just one of the salts. There's loads of them. And what we're going to do into that aqueous solution, we're going to bubble some gas through it. And I'm going to use fluorine gas, I think, which is F2. It's a diatomic molecule. Okay, so we're going to bubble some fluorine gas through this potassium iodide. So let's have a think what's going to be happening here. Now, when it's in solution, that is going to form itself into some ions, as these things often do. We've got a K plus and we've got an I minus. If you're not sure about ions and ionic bonding, again, check out one of the other videos where I explain all that there, but I'm just going to assume that you're happy with that K forms a K plus ion and iodine forms the I minus ion. So when you're bubbling this fluorine into here, we talked on one of the other ones about how keen the different elements are here at grabbing spare electrons. And if you remember that, fluorine is the most mega uber keen at grabbing electrons. So that is very keen to form very reactive negative ions, and in fact much more reactive than the iodine ones. So what happens is when you've got these F minus ions around, they're kind of like the bullies in the playground, okay? And they see this iodine hanging around with its potassium positive ion. It goes, oi, out of the way, elbows it out the way, and nabs it for itself. And you get that poor little old iodine just hanging around. So what does the iodine do? Well, it has to form some little covalent bonds with another bit of iodine and form iodine itself, the actual diatomic molecule. So basically what's happening here is that the fluorine is kicking out the iodine. It's nabbing those positive ions for itself and forming potassium fluoride. So you get an aqueous solution of potassium fluoride, and you'll get iodine on its own coming off, either in solution or depends on what they are. There's lots of these displacement reactions. Some of them form crystals at the bottom, some of them form coatings on the side of the test tube. There's various different things. Some of it forms as bubbles of gas coming off, depending on what they are. Iodine is not a gas at room temperature, so that wouldn't be forming a gas. So what we've got here is a displacement reaction. The fluorine, which is much more reactive, displaces the iodine. So what we've got is we put in F2, which is fluorine gas, diatomic, plus potassium iodide, Ki, and what we get out is potassium fluoride, Kf, and iodine, I2. Now we're going to have to balance that, of course. We've got 2 F's going in and only 1 coming out, so we better double that. And we've got 2 I's coming out and only 1 going in, so we better double that. And I think everything's balanced now, so 2 K's, 2 K's, 2 I's, yeah, that's all right. So fluorine gas plus potassium iodide gives you potassium fluoride plus iodine. Displacement. Fluorine will displace iodine because it's more reactive. Fluorine will also displace bromine and fluorine will displace chlorine. So you did this with, well, let's say you did it with sodium chloride, just salt water in there. You pass fluorine through sodium chloride, you end up with sodium fluoride. So I've just done that with fluorine. Now you're going to pause the video and do the same thing, but putting chlorine in there. So what I'd like you to do, grab pen and paper. I'll do this one in green, I think. Instead of F2, we're going to put Cl2. So we're going to be bubbling chlorine through there. And we'll have different compounds in here. I'd like you to try that first with potassium fluoride. There's no point putting potassium chloride in there because you've got chlorine in it. So we'll have potassium bromide and potassium iodide. So each of those plus chlorine gas. What does it come out with? See if you can work that out. So pause the video, have a go at those. Right, we'll start from the bottom with the easiest ones. This one is very similar to how we had before. The chlorine is more reactive than the iodine, so it kicks it out. So what we end up there is with potassium chloride plus iodine gas. And we just need to balance it up. Okay, very similar to the fluorine one. This also, we're going to get 2 lots of potassium chloride and bromine given off. And again, we need to balance that. It's the top one that's most interesting. What do you get out of that? Exactly what you put in. Nothing happens. Nothing happens because the fluorine is more reactive than the chlorine. So the chlorine won't displace. You get out exactly what you put in. No reaction. Did you get that one? So we can see here that fluorine, top of the reactivity, is the big bully of the halogen playgrounds. It's gonna steal all those positive ions and it ain't giving any back at all. So that's enough from this video here. Come back to another video where we look at some of the other reactions of the halogens, including making salts. And ever wondered how come non-stick saucepans work? I'll see you in the next video. We'll find out. Bye for now, Batty fans.